Thanks a lot for joining us. Thanks a lot, audience and delegates who are also watching us in the virtual 3D platform. We had a wonderful inaugural session in the first edition of Radiology and Imaging Summit. So now we'll have an industry perspective, very important on AI and radiology to start with. And we have two people joining us from Icons Infocom Private Limited. Welcoming Mr. Manishar Goenka, founder and CEO of Icons Infocom Private Limited. Welcome, sir. And Mr. David Lakra, Senior Product Manager, Icons Infocom Private Limited. Before I would ask Mr. Manish for his presentation, I would like to briefly tell what is going to be the industry perspective presentation right now, which is going to happen. Mr. Manish Goenka, he is a CEO and co-founder of Icons Infocom. He'll be speaking about the latest artificial intelligence powered technology available for the radiology reporting in speech recognition and various solution which is available in the market. I think it's going to be a very interesting presentation which we are all looking forward to. Over to Mr. Goenka.
Hi, thank you,
Sir.
Pratibha. Thank you, Team eHealth, and I thank all the delegates and the audience, to give us this opportunity. So basically, as she said, we represent Team Icons, and I welcome you all on behalf of the team. So here we're going to be talking a bit about the technology, the evolvement of the technology in the domain of speech recognition, which has been globally and also in India been used by a lot of doctors, a lot of radiologists to create reports, faster reports and stuff. Just to brief about Icons, we are a 20-year company, been in the domain of healthcare since a long time. We have a couple of thousand users in the Indian market who are using our speech recognition software already. We're the authorized distributor again for Philips speech processing product for seamless dictation workflow, which can also run probably, or you can automate your speech recognition, or you can also otherwise automate the entire transcription workflow. We also tied up with Medivis for their radiology information system software as well. So just to give a little brief first, as the industry has been rising, is growing with the rising levels of income, awareness, government spending, and of course the insurance. These are the key drivers for the Indian healthcare industry. Currently, the estimate spending, as we all know, in the Indian context, is about 5% or less, a bit less than that of the GDP, and this growth is going to grow in leaps and bounds in the years to come. With this segment in the healthcare segment growing so high, the biggest beneficiary of this would be one of the segments, I would say, is the radiology or the teleradiology domain. With emerging trends in technology, it is interesting to see the tremendous scope that this sector has to offer. The world of imaging and technology is constantly evolving, and thus it's opening up the vast new world of innovation. As radiology is the first step towards treatment or and general healthcare, it is really important for the radiologists to be equipped with technology, let's say PACS, RACE, and further tools which can help them in their faster TAT. Um, Yet protect data, patient data, which is very important, and also yet let them cope up with the growing patient inflow with ease of accuracy, diagnosis, and precise report. One such great tool which has been widely used globally is the Dragon Medical Speech Recognition Software by Nuance, and we represent Nuance in India. So with the new version, which is the Dragon version 4, which my colleague David here will also try and show us brief demo if time permits us. Okay, is embedded with the AI technology now, which is much more faster and accurate than the previous edition. So I'll just tell you about the new offerings what we have in the version 4. It's about 25% more accurate than the previous version 3. It does not need any training now. You just install the software and start using it with a minimum accuracy level to begin with, about 97 to 99%. Those days of the keys and the serial numbers have gone. Now you can start using a login the system with a unique user ID and a login password, which means radiologists can install it on multiple Windows-based PCs and use it from there. With the deep learning technology and the artificial intelligence presence, it's pretty much accurate. Also, it has an improvised hidden mode option. So basically, what does speech recognition do? The key highlights would be it simplifies your workflow. There are challenges in any organization today where you have to create reports, and if you're dependent on somebody, it takes a lot of time for you to be to create reports and everything immediately and instantly on the computer screen. It's also saving a lot of time and effort. It saves on your transcription cost, which means it has better return on investments. It reduces your dependency on a stenographer and overall improves patient care reporting. You can have a precise or lengthier report, depends, because you no more typing, you're just dictating to the software, which means there's less of fatigue, and it's pretty much accurate. The key benefits: quality documentation, where you do not have to create or type small reports. You can actually elaborate the report now because you're no more typing, you're just dictating, and it's dictation. You're used to giving dictation, and when you dictate to the software, instantly things are getting typed. It increases your efficiency because the software, our speech recognition software, is completely offline. It does not need an internet connection or internet connectivity. It is completely secured, safe. Your data is private. It's because all your data resides on your local PC, which means it's not going out, unlike options where you have, which is online, which needs internet connectivity. So our Dragon does not need all that. It is completely offline. Your data resides on your PC. Nothing goes out of your PC. So it's secured, safe. Your data privacy is also maintained. It improves your PACS, RIS, EMR usability. We have many implementations done where the software works seamlessly on all the PACS available in Indian market and the RIS. It works in GE, let's say Siemens. You talk about Fuji. You talk about the Indian brands like Medif, MedSynaptic, and so on. Because you are, as an adult, basically we speak about 110, 120 words per minute. That's an average talking speed. Okay, there are people who are faster than this. An average typist would do about 40, 50 words per minute. So if you look at when you're dictating to the software directly, it is very fast. You're three times faster than typing, so it's quick. Your turnaround time of making reports are much faster. The software comes preloaded with 80 medical specialties, and one of them is radiology. So you can be rest assured about the spelling errors and stuff. So you can focus on your reports, and the software delivers everything out very seamlessly and accurately for you. So it's there were issues earlier. People used to talk about speech recognition doesn't understand Indian English accent and stuff. This is far accurate. It understands Indian English accent. It is simplified the way of using it can be compatible and be made available to use on any Windows based your system. It supports all tags, which let that be an online platform or offline platform. It'll work on those. It has we've added about 400 plus customized medical radiology related templates, which we've added for your convenience. You can add your own. You can delete as well if you do not want them. You can remove it. You can add them. You can make changes also in that. It needs no internet connectivity, which means you can use it even on these places where you do not have 4G or 5G connectivities. You just you can be offline and dictate everything. It saves time. You need so if you're making reports manually, generally it's about an average would be person would be using mouse and making about a couple of mouse clicks and mouse movements. Here it saves your time. You toggling between you and the screen gets reduced, and of course improved and more accurate patient records can be made. People talk about EMRs and people talk about recent packs, and we're talking about the whole thing about going electronic. But the biggest hurdle comes when it comes to typing. That's been our experience, what we've seen. Okay, with this, you do not know. I mean, even if you don't know how to type, you can still be faster than any typist in the world. So it also saves a lot of time, as I mentioned to you. Yeah. So there are two solutions what we can offer. One is a speech or front-end speech recognition software, wherein you're speaking in front of the PC and the software instantly types everything onto your application. Let that be RIS, EMR, or PACS. Then we have an offline solution wherein a doctor can actually on the go can record things onto a smart digital voice recorder, and we have a complete workflow. When you record into the recorder, you can connect it, and you can just dock in on a docking station, and the entire workflow happens automatically, where the reports can either go to, the audio file gets transferred to the PC where the software is installed. It transcribes everything automatically. It can then go to a proofreader if you want to, and the proofreader can edit the document and send it back to the doctor. So there's a front end and a back end speech recognition. Front end would primarily depend upon it reduces your dependency on a stenographer. It cuts down recurring cost of transcriptionist. It's pretty much accurate. Dictate anywhere into your own applications. Understands Indian English accents. Create more complete patient records. Reduces the TAT as I've explained. So I'm going to skip this. In the backend speech recognition, it is meant for those who do not want to use speech recognition directly, or still want to continue the same legacy way where they're dictating to a stenographer. So again, with these solutions, you can make it, you can further automate it, where the doctors do not have to have somebody, a stenographer sitting next. They can record everything. They can dock it on a docking station. The entire audio file goes through the process where it can go to a designated PC, where your transcriptionist can either listen to the audio and type it and send back the reports to you, or or you can have, if you have the Dragon install on the PC of the transcriptionist, the software can transcribe everything. The transcriptionist can just do the proofreading part and send the final draft to the doctor. Okay, so that's front end speech, back end speech recognition. What we have. So it's basically talking about the product, which I'll skip right now. So we just recently got into this agreement with Medavis for a radiology information system, which we plan to launch. I mean, they've been there, but this is what we will be doing. Our software seamlessly works on this. Speech recognition works very amazingly. We've tested it and we've tried it. Uh, Anybody who would like to see a demonstration of this as well as the Dragon, we can we can have a one-on-one demonstration also arranged for you. So a little bit about Medavis. It's founded in 1997. It's been installed in it's a German product, which is, so you can be rest assured about the capability of the product. It's been it has about 25 years of experience in the radiology workflow management, and it's been it's been widely used in European market. So some of our partners who we partner with, we have GE, we have MedSynaptic, we have Siemens, Fuji, Medif, Philips. These are a few of our partners who we partner with as well to sell to provide our speech recognition solution. These are a few of our existing customers who are using it. The list is pretty exhaustive. I'm just giving a few. We just have few names which we added to it. So if you look at, most of these hospitals are using it. We also have many individual doctors who are using it. Now, since we have a bit of a time, I'm going to ask David here to share, to probably start a small demonstration of the Dragon Medical 4.2 for you guys to understand. As I mentioned, we can also have a lengthier demonstration, one-on-one demonstration, a customized demonstration based on your requirement, even one-on-one later sometime. This is just to give you a little bit gist about how the product works. So I'll just transfer it to David. David will take it up from here. Thank you for listening to me very patiently. Thank you so much.
Thanks a lot, Mr. Alex. I would like to quickly ask Mr. David to take it up and yeah, give us a demo.
Thank you, Manish. Open Microsoft Word. Open new document. MRI brain. New line. Observation, new line. Moment artifacts are seen as the patient is uncooperative. Full stop, new line. No focal areas of altered signal intensities are seen in the cerebral hemisphere. Full stop, new line. The posterior fossa structure, including brainstem and the cerebellum, reveals no abnormality. Full stop, new line. Pituitary and the corpus callosum are normal. Full stop, new line. The ventricle system and the basal system and the cerebral sulci are normal. Full stop, new line. No midlife shift is seen. Full stop. New line. Intracranial vessel shows normal flow voids. Full stop. New line. Visualized portion of the orbis and the paranasal sinus appears normal. Full stop. New line. Impression. New line. No significant brain parenchyma abnormalities seen in this study. Full stop. New line. Insert signature. So that was the small video of how the Dragon software will work. If you want a more elaborated demo, we can contact us and we can show you 101 demo for you. And that's over from me. I'll transfer pass on to Manish.
Yeah, I'm sure you guys had like the demonstration of the software. Thank you, David. Uh, yeah. So
Yeah. Thanks a lot to Mr. Goenka and Mr. David for showing us this wonderful AI-powered technology, very useful. I can see even journalists will be happy to use this. You know, we do take a lot of notes. I would, you have any points to add in, Mr. Manish here?
No, so basically, as I mentioned to you, if anybody would like to have a one-on-one demonstration, we'll be more than happy to, give them a presentation. We already have a good, huge client base in India who've been using it. As I mentioned, we've been in this domain for the last 20 years. We launched the Dragon Medical version almost about 8 years back. The product has evolved from a time where it used to take about a couple of hours to train and use. Now, as I mentioned, you just install and start using it, so it's pretty much accurate, and it's come a long way as well. Yeah, it's come a long way. The licenses, as I mentioned, it's a perpetual license. A lot of people have this question. It's a perpetual license. The license never, once you buy it, it never expires. You can start you can once you buy it, you can use it. It doesn't need any subscription, so it's a one-time cost basically. uh, yeah, that's
Yeah.
all about thank you,
Yeah.
you guys. Yeah,
Yeah.
go ahead.
Thank, yeah, yeah. Thanks a lot for making it and showcasing your, product here. And we would like to thank you as a token of appreciation. We would like to give you the speaker certificate. So I would like to ask my DD. Thanks a lot for joining us, Mr. Manish Goenka, founder and CEO of Icons Infocom Private Limited. Thanks for joining in.
Thank you.
Yeah, yeah. And thanks a lot, Mr. David, for joining in and showcasing the product and how it can be used. Thanks a lot.
Thank you.
Yeah. For the audience and
So
delegates, we would like to say that we would like to
no, go
say
ahead.
that there is a 3D platform available. You can ask your interactive question. Let's make the session more interactive. You can ask more questions in the platform. We would be able to take it to the panelists. Next, we have a very interesting session coming up. It is about the future of artificial intelligence, the prospects of artificial intelligence in radiology. So, before ending this session, I would also like to thank all our sponsors here who have actually made this possible. For coming, for making this radiology and imaging summit happening. So I would like to thank our sponsors: BPL Medical Technologies, Fujifilm, Elsevier, Castream, Icons Infocom Private Limited, Newsoft, and Aqua. Thanks a lot.
Is your imaging facility currently using X-ray film for radiography? Would you like a way to accelerate your workflow, increase cost efficiency, and optimize image quality while saying goodbye to your darkroom, chemicals, and ongoing X-ray film purchases? Or perhaps you'd like to upgrade from CR and eliminate the extra steps required to digitize the image from your cassette. This can also free up your CR system for use in another location. If so, it may be time to go digital, and the CareStream Focus 35C detector with powerful Image Suite software gives you an easy and affordable way to do just that. Best of all, it's a smart financial move because there's no expenditure to replace your wall stand, overhead tube, or table. You can keep them all. The Focus 35C detector is a remarkable wireless detector that allows instant image capture and access, while still leveraging your existing X-ray equipment. Powered by our Image Suite software, the Focus 35C is the perfect solution for high-quality DR imaging. It can also provide mini PACS capabilities, all at an affordable price. CareStream X-ray Solutions. Right for today, ready for tomorrow.
Thanks a lot for joining in on the first edition of Radiology and Imaging Summit 2020. It's the very first panel discussion and very important one, and it's on future prospects of AI in radiology. So I would like to introduce the panel here, and I will hand over to the moderator then. So without further ado, I would like to introduce Dr. Vidur Mahajan, the Associate Director and Head R&D Mahajan Imaging and Caring. Thanks for joining. And Dr. Vasanta Kumar Venugopal, Imaging Lead
Hi.
Caring. Hi. And Mr. Vivek Saxena, National Manager, Healthcare IT, Fujifilm India. We have two more speakers. Yes, Dr. Venkat Ramana Sudigalli, FRCR, Consultant Radiologist, NHS UK, Director and CEO, Excel Hospital, Ambassador of UK College of Radiologists. We'll have one more speaker who will be joining in, and one lady in the whole panel, Dr. Tejendra Kataria, Chairperson, Radiation Oncology and Medanta Cancer Institute, Medanta, the Medicity. She'll be joining in soon. Without further ado, I'll just give it to Dr. Vidur Mahajan, who will be moderating the session. Over to you, Dr. Mahajan.
Thank you so much, Pratibha. It's truly an honor to be doing this, and we've managed to put together an illustrious panel. Very proud of the eHealth team to be able to pull this off. Especially, I know you guys were a little short on time, so kudos to you. I think much has been talked about the development, testing, and implementation of AI in radiology, and I think the one of the pivotal moments was several years ago. I think 2016, when Professor Jeffrey Hinton, who is the one of the fathers of deep learning, commented that radiologists are going to now be replaced by machines and artificial intelligence more specifically, and it's just a matter of 5 years. And here we are in 2020, ironically, in a discussion that's on the future prospects of AI in radiology. But I think one of the key takeaways I would want from this panel for the audience would be to get a sense of where we are in the field of AI, and specifically in radiology. And with that, we have my close friend and colleague Vasant, who's a radiologist who spends about I would say 80% of his time testing and deploying AI algorithms. We have again good friend Vivek Saxena, who leads the PACS business for Fujifilm. Excited to hear what he has to say on the subject. We have collaborated on several fronts in the past. Then we have Dr. Venkat, who has extensive experience of NHS, of innovation at NHS, and also runs his own hospital. And we also discovered a common connect yesterday, which was very interesting. So as we wait for Dr. Kataria to come in, I think ma'am is joining. We'll give her a couple of seconds. Yes. Hi, ma'am. Welcome. Thank you so much for joining, Dr. Kataria. Dr. Kataria, as many of you may already know, leads the radiation oncology department at the Medanta Medicity. I think there are some technical issues at her end, but I'm very much excited to hear what Dr. Kataria has to say, because radiation oncology is one of those fields where automation and automated segmentation, image processing, even machine learning has crept in very silently. So very excited to hear that. But we'll start with maybe Vivek. I'll start with you. But I think Dr. Kataria is there now. Sorry.
Hi, I'm sorry for the interference.
Yeah,
Right.
no problem, ma'am. Ma'am,
Good
so we
morning.
were just going to start with you.
Okay.
Ma'am, can you walk us through, over the years, we'll talk about technology first and then dive into AI specifically. But how has technology come into radiation oncology specifically over the years? Like you've been in this field for several years, and maybe even decades. Ma'am, if you could walk us through that journey of technology creeping into the field of radiation oncology, and then and then maybe share your thoughts on the future of AI in radiology as well.
Right. Thank you, Vidur. And thank you, eHealth, for getting us on board for this very important panel discussion on AI in radiology, the future. I've been in the subject, as Vidur said, for over 3 decades, and we started off way back in the 80s and 70s with COBOL systems. And the planning was done manually. At that time, we had the ISO charts, which would be taken on by the physicist, and as the residents, we would plan these cases. And that would take us about a day or 2 days to get one plan ready. But then we moved on to 2D planning systems where one axial section was taken and the plan was done. That would again take half a day. And then as the computer systems improved, the computation moved into the radiation planning domain. And in the last 1 decade, we not only planned completely on the CT-based images, almost 1.5 decades, we also do the treatment delivery with the complete image guidance and virtual CT scans, which are done within the treatment room, and also robotic systems which automatically take the digital images, overlay the images, and then correct the position of the patient while in real time. So intra-treatment correction is being also done because of the advancements in the computational systems and the radiology. And this has, in a way, been boon for our patients because we have moved from uncertainties in the patient setup and the treatment dose delivery to precision medicine. So radiation therapy, by virtue of being computer-driven and radiology-driven backbone, it is a precision medicine or a precision therapy domain, which was one of the first ones to move into the precision medicine. And the challenges have been that moving from manual to this kind of automation needed training and time and dedication. And we needed these resources. They are expensive resources on the technology part, but then they are very human intense also because you need to be very dedicated and also be sure that you are able to deliver a quality assured treatment. So I think that would sum up our journey over the last 3 decades. Vidur, if there are any specific questions, I'll be very happy to take them.
No, sure, ma'am. I think that lays the breadth of where we've come very very well, especially in terms of time saving. Right, going from few days to few minutes itself is quite a testament to the power of technology, of course. Ma'am, I will come back to you to get your thoughts in a bit. But Vivek, if I could bring you in at this point. Can you, give us a little bit of the lay of the land, like, where is AI today? Both Fuji's perspective, your personal perspective, and then also if you could share a little bit about what precisely Fuji is doing to bring these technologies to your customers.
Sure, Dr. Vidu. Thank you. Thank you very much for this invitation. I am honored to be a part of this panel. Thank you very much. Myself, Vivek, I'm from Fuji. And with respect to the AI, as per my understanding, the AI market is still in the emerging state, and wherein mainly the working is happening. Majority is on the detection and quantification applications and the lesion characterizations. If I say, focus on the radiologists are mainly on the efficiency and the productivity. Work list prioritization is the main. If you ask me, if there is a detection, then there is that need to be prioritized on the work list. Integration with other clinical applications, that is also happening. And I think the market in India is also not different, very different with respect to the global market. The majority of the customers is still using as a research product, pilot projects and clinical trials. And Fuji is also into this, into the artificial intelligence. What we have done it, this Fujifilm's AI development initiative will harness the power of artificial intelligence to enhance its imaging and healthcare informatics Synapse portfolio, which includes the Synapse PACS and the Synapse VNA. We recently released our latest information, which is a Synapse 5 PACS. The convergence of AI and the server-side rendering, which is like Synapse PACS, is a great example of a potential to realize considerable positive impacts on the AI in the near future. We clearly
Could
see.
you expand on that? Sorry, Vivek, I'm jumping in. Could you expand on what do you mean by server-side rendering? Because our audience may not be as technical.
Yeah, surely. So in the Synapse 5, this is one of the unique latest technologies what we have launched in with respect to the Synapse 5. So if you see the old PACS scenarios wherein wherein the entire data set is actually need to be transferred through a local area network or to a WAN to a workstation to analyze and to analyze the data on the workstation itself. But once we are talking about a server side rendering, so it's very fast, it's very unique technology. What it does, it actually do all the rendering onto the server itself. So the time taking for the images to not to be transferred onto a workstation. It is just a pixel sharing what is happening onto, and it's a completely DICOM enabled and certified image intelligence what we are using it in this. So it actually gives you fastest response onto the client side with respect to the high data which is generating from the modalities like CTs and MRs, and the big data which is coming on. So it actually gives you a very fast response. That is, and top of it, the bandwidth requirement in this Synapse 5 is going to be very small as compared to the old systems, the old technologies what we used to have it. Even I would say the Synapse 4, which is the prior release of our packs, that actually works on a server side, and that actually works on a server and client relationship. But this is a completely new technology, and we have a very good installations in India. We have done it recently in Kokila Dhirubhai Ambani in Mumbai. That's fantastically, it is working there. We have in Lilavati Hospital, we have in AIG Hospital. So and we recently have launched it, going to launch it in Hinduja Hospital also. So this is the response what we are getting it with respect to the Synapse 5 is really perfect, and the way the appreciation is coming from the end user, it's really fantastic. So that's altogether is a new technology what we are trying to develop, what we have developed it. And on top of it, if I talk about AI, artificial intelligence, so there is a new platform which we already have launched in abroad. So from US and Tokyo we have already done it. So the platform named as Rely, that's a artificial intelligence platform from Fujifilm. So what we are trying to do it by using this platform is actually uh, giving a seamless interface to the users. So in collaboration with Synapse 5 along with the Rely platform, so it's going to be a unique interface which actually enables the end users to do the high-end post processings on the Synapse 5. On top of it, it is getting a priority work list using a Rely platform. On top of it, it's actually giving you all the nodules detections, automatic detections by using an artificial intelligence engine built in Rely platform. So this is Fujifilm is going on with respect to with respect to the new technologies, the
Great.
artificial intelligence, right, sir?
Great. No, I'll quickly, on that point, bring in Dr. Venkat.
Sure.
Dr. Venkat, Vivek just mentioned that, currently AI is more in the research domain. It's more, there's a lot of clinical trials going on. Do you agree, or like, can you share some of your experience at the NHS, within your hospital, and just generally, your thoughts on the subject?
Yeah, sure. Thank you, Dr. Vidur. A pleasure to see you because we know indirectly through your brother Kabir, who I
Small world, sir.
spoke
Very
to
small world.
recently. So it's a very small world. So being within India, we came to know later, and being Kabir being abroad, we came to know earlier,
Correct.
which is the beauty of technology,
Correct.
So the world is getting smaller.
Correct.
So I've been a consultant radiologist and in the field of PACS imaging technology related since almost 2 decades. Um, and as you know, the PACS, when I was a junior doctor, the PACS was just getting in, and I was probably one of the last persons who actually held a film in my hands in the Western world. So I get the perspective of having a non-PACS, non-digital method of reading films, as well as completely digital transformation to PACS everywhere at the moment. So I'm lucky in that sense. But what happened with PACS was that was a stepping stone for the future to come in, with whether it is AI, whether it is ML, whether it is NLP, VR even. So there are so many things which came on once the PAX revolution came in about 10, 15 years ago. And I think in India, since the last 5 years, the uptake is much, much more. So what I think is the
Can
innovation
you
in terms of,
elaborate on that, Dr. Venkat? Sorry, I'm
pardon?
cutting you, but why is PAX important for AI? Like, if you could just elaborate on that
Yeah,
for a couple of
so
minutes.
sure. Yeah, that's a good question, Vidur, because as I said, PAX was a stepping stone for the future of any tech related medical care to come in, because we had the obscene amount of data that we can store, that we can play with, that we can really evaluate. And that was a high quality data because patients imaging, especially we could, anonymize, we could send it anywhere in the world. So that was a stepping stone in data formation. And now we have big data because of PACS, which can work around so many things. And with this information that we all have, we can, use technology to the next level, which is AI, ML, NLP, all those things which is coming in. So PACS is a very basic setup, which we all were needing in this millennium, which happened very, very nicely. So that's why I think that was a stepping stone. But after that, things kind of slowed down a bit because the adaptation of AI, as you said, Jeffrey Hinton was saying that we'll all be wiped out as a radiologists. Clinicians will be looking at the images with AI help. All these things were coming up. Even Vinod Khosla, the venture capitalist from USA, recently said that he's not going to fund anymore for radiologist spaces because we are all going to be like robots. We are not going to be there in work anymore. But obviously, that is all kind of just attracting the headlines. But the actual thing came out from a person called Toby Walsh. I don't know whether you know him, but he's a very nice, reputed physicist from Cardiff University. And he definitely said one thing which sticks in many, many persons' brains, which is AI cannot replace a radiologist, AI or ML or whatever technology which comes through. It can augment the work for a radiologist, and patients will be the ultimate beneficiaries because it will improve patient care, it will improve the pathways, it will improve the speed, agility. So there are many things which can do with AI. We will forget about whether they're going to replace the radiologist because that is not going to happen in our generation. That is for sure.
Thank you so much for that insight, Dr. Beckert. And it has also been said, I think, by Professor Kurt Langlotz at Stanford that radiologists who use AI will replace radiologists who don't, which is I think true for most technology, right? You could like doctors who don't use WhatsApp, are probably being replaced by doctors who use WhatsApp. Especially during our hashtag COVID times.
Yeah.
Before I bring in Vasant, I'll just go back to Dr. Kataria. Ma'am, you had mentioned when we were talking before the session that there are some interesting use cases of AI, especially on the texture analysis side of things. If you could just quickly walk us through some examples of those and how you feel they bring about clinical impact. Ma'am, you are on mute, ma'am.
Sorry. So that's a very interesting question, Dr. Vidur. What it means is that the textural analysis is the texture reading on the CT pixels or the voxels, what you call, and then to be able to interpret the information thereof, which is not yet either clinically discernible or the patient is not symptomatic enough to give you. Because the traditional methods of medicine have been history taking, physical examination, and then investigations. But then there is a turnaround. We are just going around in 360 degrees to the point where probably the disease has just started within the patient, and the patient was incidentally investigated for something like an executive health check for a patient who's a smoker, and we pick up a ground glass opacity or some small changes. But then the texture analysis can tell us that it is a predating cancer or it's an infection. So we can differentiate between a tuberculosis, an infective pneumonia, and a cancer. So if the suspicion is strong enough, then the radiologist can guide the clinician like me or the physician that the patient needs a biopsy. So a patient for lung cancer, let's say, presents to the clinic in stage 3 when he gets symptomatic. But you can predate, like in a mammogram, you can predate the tumor to 2 millimeters, 3 millimeters, and you can save lives. So similarly, texture analysis on a CT scan can bring in a revolution to predate a cancer which is not yet clinically manifest or radiologically even manifest. So that is where the beauty of the textural analysis or the AI in radiology lies. It doesn't mean that it's going to replace the radiologist, like you said, but it will, augment the working of the clinic or the working of the radiologist in helping a patient. And the other side, what this is predating or maybe a diagnostic realm on the texture analysis, but as a radiation oncologist or a person who looks after the cancer patients, for us, it's important whether we can predict a response. A patient has undergone a treatment, and then we do a follow-up scan as to how much of the tumor necrosis, or we right now are using the PET scan, where we say the SUV value fall down more than 30% in a certain period of time, says that this patient would respond well. Or for SBRT, which is the high end of radiation, if 30% reduction in the SUV value is there or necrosis is set in, we would say these patients would get cured. 70 to 80% of them would get cured in 18 months' time. So, we are going into that domain. So one is diagnostic, then is predictive, then is prognostic, as to how the patient's prognosis is going to change with a treatment, or whether we should bring in something else. And the fourth area is, radiomics with genomics, whether the radiomics can predict the type of the cell or the genome of that cell. So that is the highest, and I think probably you will bring that in later. And the other thing is, for as a physician who's treating cancer patients, whether we can predate a recurrence on the scan. So we are seeing the MRI in the brain tumors, especially in glioblastoma multiforme. The patient is not symptomatic, but if we can see the diffusion restrictions started appearing, or there is enhancement that is occurring, or edema has set in the area which is away from the treated field, is that a harbinger of recurrence? So then we put up antennae and call the patient earlier for follow-up. So these are some of the areas where, the texture analysis is helping us in the clinic.
Got it. No, ma'am. I think the reason a lot of this is now possible using AI is because at its core, these algorithms are able to figure out many of these features themselves, right? If you are able to find a data set that has, say, 5,000 MR mammograms of patients who had a good prognosis and 5,000 MR mammograms of patients who had a bad prognosis, theoretically, one is able to use these algorithms to kind of figure out those patterns that may be often not discernible to the human eye. Like some of the most cutting edge work that I've personally seen has been, and this is done, by a startup in Bangalore called Predible Health, where they are trying to, detect EGFR mutational status of lung cancer from CT scan, right? Which is, it just sounds absolutely berserk. And then, of course, there are papers on detecting IDH4 mutational status from brain tumor, from brain MRIs. Just a 3D post-contrast brain MR is able to do that. So many of these things, we can't see. We are limited by our eyesight and our insight. Moving
So
on,
I'd like to add there,
please,
can I just pitch in,
please,
so
please,
I'd
ma'am,
like to add
please.
that to that, the IDH mutational analysis. So we've recently concluded a thesis for about 60 patients for one of my DAB students, and we found that in 80% of our patients who had IDH mutation, the MR features are different from the patients, 20% of them who do not express the IDH mutation. So there is an increased enhancement, the MR diffusion restriction is higher, and the edema is much more. So these are the preliminary studies, but you're right that we can kind of start looking at the immunological and the immunohistochemistry or the genomic expression also now.
Oh, absolutely, ma'am. And imagine, the possibilities if everyone starts pooling all these data sets together and, then trying to figure out some of these things. I'll now, bring in Vasant. Vasant, I think it seems that looking behind you, you have taken all the AI that you can and put it right behind a radiologist. So can you walk us through a little bit of how is it to be a clinical radiologist who diagnoses patients every day, but yet spend a significant amount of time on AI. And if you could just walk us through some of your work and how radiologists on this session can kind of take away from that.
Sure, Vidya. Thanks. Thank you for the introduction. Thanks for giving me this opportunity. So I would take a step back and I would like to give a broad perspective of what's happening, and I would use certain generalized personal opinions to put things in context. The topic is about future of AI in radiology. So we should know what has happened in the past and what's happening in the present. So the past, again, a generalized opinion, has been marred by hype, right? There's been a lot of hype. This is happening, that's happening, so much is happening. None of them came to fruition, and things went for a momentary pass. So in the present, there is hope. How did this hope come? The hope didn't exactly come from the technology side. The hope, in fact, came from the adoption side, right? Because of COVID, we saw that there is a eagerness to adapt to new solutions, digital solutions, technology solutions, and there is an understanding that there is a huge potential for AI solutions getting adapted faster than before the onset of this pandemic, right? So that's where I see there is a lot of hope in future, and it's very important that radiologists take maybe control of the situation and help all these AI solutions see the future in the right way. When I and Vidur started, caring about 2 years back, we thought that the problem is in integration and adoption, right? We thought that the AI solutions are working fine, and when the only problem why hospitals are not using it because they are not able to integrate the solutions in a easy way. That's why we focused in our initial days of caring as an integration platform, right? We would integrate the AI solutions in clinical workflow and try to see how it works. We did that across our centers at MI and multiple sites in India and even in Brazil. So we figured out that the AI is not working in a very valuable way, right? I'm saying valuable way because AI was definitely good. Its performance was very accurate in controlled settings, right? If you take a controlled experimental setting, make radiologists sit in a room, mark 100 X-rays, and run an AI algorithm on the same solution, it works perfectly fine. But if you put that AI in a clinical system, it doesn't offer any value, right? Even it succeeds in correctly identifying 95% of the cases. The 5% of the cases where it fails actually overcompensates or fails the value which would have offered by correctly identifying the 95% cases. That's when we thought that probably we should take a step back and look at the ecosystem from a broad perspective, right? So we started identifying how could we help the entire the taking the AI to the clinic funda. So we then started in collaborating with multiple AI companies at multiple touch points, not just integrating the solutions in clinical systems. We started working them from defining the clinical problem, right? What exactly is the clinical problem you should work on? Not just since you have 100,000 X-rays available for free, you just can't develop an AI solution for chest X-ray and dump it on radiologists. We don't want that, right? So we have definite problems. Our workflow is filled with problems, right? Starting from patient scheduling. The center which I am sitting is deaf call center. If I go upstairs, there will be at least two patients who are disappointed with the inaccurate appointment or uh, not getting their turns at the right time, and that's the problem number one which we face every day. And then acquisition part, right? How do you acquire the scan in the most efficient way without compromising on the quality and not taking too much time, without compromising on the waiting times. And then and then the diagnostic part, how do I get the images in the way I want, and how do I interpret the images in a time efficient manner? And once I have done that, how do I communicate those results of that interpretation to the clinician in a very, again, useful way? So as you see, there are multiple touch points where AI solutions can be built or offered to improve the entire workflow. So that's number one. We started working with identifying problem areas and helping companies to start working in those problem areas. The other biggest problem every AI company in the earth faces is data, right? How do you get the right data? How do you get the right curated data? And we are all aware that there is a large gray zone around how do you acquire data in an ethical way, how do you handle data in a very ethical way, and how do you curate the data in a very ethical way and help AI companies access the data. So we started working on that front also in a very transparent and ethical manner. And the third problem which we felt that is the curation of the data by experts, right? Most of these AI companies were most of them, not all of them, are using shortcuts for data curation, right? They don't use the well qualified experts who should probably be tagging the data. We all know that uh, how the good the data is, the good the algorithm is going to be. So that's when we started building tools which can help bring in radiologists in a very efficient manner to curate the data and provide that to the AI companies. And the next part is validating these solutions before releasing them into the clinical workflow. Again, this validation should be specific for a site. We all know that the AI solutions are not very generalizable in the way they are built. They need to be tutored or titrated to the site specific parameter changes. So that kind of figuring out what minor changes should I do so that this algorithm works at my place is the entire validation part. So we also started working that. So Vidur, if you give me permission, I will just log in into the portal which I use day in and day out to do all these things. I'll just take briefly 2 minutes.
Sure, we can give a couple of minutes on that, and then we'll move on.
Sure,
Great.
sure. So I'm just quickly sharing the screen. So this is the portal which I use day in and day out to do all the things which I just showed you. This is my login. This platform is called Carpal. So it's the demo version of this platform is available for everyone to use. You can reach out to me. I can walk you through how to access this. And I'm very fortunate to have access to so many AI solutions to validate and test. Some of them are commercial solutions. Some of them are open source solutions. So, and then you see this entire dataset manager. I use this dataset manager in the platform to identify data which can be curated and provided to companies or used for my own internal validation, processes. And then there is this entire annotation platform. I told you that getting images curated by experts is a very painful process because we need to provide those images to the experts in a very easy way so that they can look at those images in a very intuitive manner, not needing to do a lot of technological hearsay from experts. They should be able to do it by themselves. So that's the idea behind building this entire platform. So you can see here you can easily get solutions curated from radiologists. So you have tools there will be this curation tools, annotation tools, and it's very intuitive for radiologists to use. So this is what we have built to again help the AI companies. Once they come up with a solution which is good for deployment, I also personally test it on our data before integrating that in our clinical workflow. We have very specific set of rules to do those validations. We use scientifically curated data and scientifically inferenced data to do that validation, and I can quickly give a broad overview to other radiologists in our in our centers how this particular algorithm will help their workflow so that they will also start coming in and start using these solutions. So that's broadly I wanted to tell Vidur, right? The future is very promising. Radiologists should take control and we can help you. So that.
So thanks, Vasant, for that futuristic peek into what is possible. Of course, there is a slight amount of bias there on my side as well. but I think it would be. I think we can also. I would urge the audience to please ask as many questions as you'd like. We want this to be very interactive. There is one question that has come in, and maybe we could address this, and any of you would like to take this on. The question is, even though there is a lot of hype around AI, how exactly is this technology used in hospitals in India? Vivek, I'm not sure if you want to take that, or Dr. Venkat, Vasant, whoever would like to please chime in.
Uh, shall I come in or?
Yeah, please carry on.
Sure. Or Dr. Venkat, I noticed that you. Vasant, go ahead.
There are
Please.
certain technologies which we are using at our centers across Delhi. One of them is, how do I quality control the chest X-rays which are being reported radiologists across centers, right? Radiologists are busy, and chest X-rays is considered to be a quick turnaround scan, right? And it's highly likely that even a well qualified experienced radiologist would miss a subtle finding somewhere hidden behind the rib, or in the retrocardiac region, or behind the breast shadows. So how do we kind of avoid those mistakes? That mistakes at a large scale level, out of 100 X-rays, or missing one X-ray, that's fine, from the hospital perspective. But from the patient perspective, that's going to make a difference between life or disease. So that's where we have started using QC tools, purely AI controlled QC tools, right? Even though we can't use those solutions prospectively, we can very well use them retrospectively. We run all the X-rays that are being reported by our radiologists across our centers after they have read those X-rays through multiple AI solutions to pick out those X-rays which have been reported as normal, but reported by AI as having a abnormality with a high probability score. So we end up getting, out of 100 X-rays, say 3 to 4 of them. And I personally review those X-rays to see if there has been something which has been missed by the radiologist. And also, head of our departments at certain centers help me in doing that quality control. So this kind of adoption of AI can happen right away. It doesn't, involve direct kind of prospective role in the healthcare delivery, but it definitely, right, Dr. Vengat said, augments the healthcare delivery by radiologists. It kind of identifies your pain points and helps to fix it. That's one way which we use.
Got it. Great. I think Dr. Tejinder has
Thank you,
something to say, ma'am.
Dr. Vasanta, for that information, because the QC tools would ensure that you are able to kind of correct the anomaly if that has crept into the system. But going forward, when you have these systems, automated systems made available to a larger audience or to a larger group of radiologists, how do you ensure zero tolerance there? So that is what I would be interested in knowing, if you've already reached that or your systems are able to get there.
So there is always a human in the loop, ma'am. So even in the retrospective part, we are not just accepting the alarms by the AI, right? If the way QC used to happen at our centers is, we used to randomly pick 10 cases and check if there's something has been mixed by radiologists. That's a kind of a random pick and choose kind of QC. And now we are moving on to total QC, right? You put the entire bucket of cases through the AI system and pick it, right? It's still possible that there might be some lesions which are missed both by the radiologist and the AI, but we will eventually hope to reach that point where we are properly able to pick those cases. But again, it's still a work in progress. We will eventually reach there where we have zero tolerance to AI misses.
Yeah, so there's a learning curve to it, and that is what, as physicians, as radiologists, as doctors, we should keep that in mind. That technology is there to assist us, but then the human supervision has to be done, and also there has to be a feedback loop which is available for you as a caregiver, that you can identify where the mistake is happening and how it can be minimized, and then go back and learn from there, and then that those mistakes should be
openly discuss and be available for the new learners who are coming in. So this is how we have developed our systems over the last 2 decades.
Exactly, ma'am. Exactly.
Absolutely, ma'am. Dr. Venkat had
Yeah,
something to say,
so
sir,
it's a
please.
very nice example which Dr. Vasant said. I just want to continue. I'm a senior consultant to one of the biggest telerad companies in the world, which is London based. And so we have an Israeli company which provides AI solutions to us. So we are just about, in the process of introducing from early this year. So what it does is we do one of the algorithm that we developed is for intracranial hemorrhage, and the guidelines from the UK NHS is that every stroke patient or query stroke patient has to have a CT within 10 minutes and also reported within 10 minutes of they coming to the thing. So it's not always possible because there may be some other urgent cases, etc. But with this AI solution, which detects intracranial hemorrhage very fast, so it takes less than a minute to identify if there's any hemorrhage. So that flags up. But at the moment, we are not just using that one. We are also having a human interface because it's just not the hemorrhage that we want to detect. We want to detect any abnormality. But it's important that even the tiny ones have been able to be detected by the AI, which flags up and then gets rechecked by one of the consultants before giving out a final report. So clinician gets an alarm saying that, look, there may be a hemorrhage. It's not yet confirmed unless the human factor comes in and verifies it. But at least they won't start thrombolysis, till that crucial few minutes. So this is a classical example where AI can help you in the immediate patient management of a stroke patient.
Dr.
No,
Vidhu.
absolutely, Dr. Venkat. And I think, Vivek, you have
Yeah.
something to add?
Yeah, Dr. With respect to this question, how exactly the technology is used in hospitals in India. So, with respect to the market, if you ask me, we are in touch with the customers, and the response is very positive. The customers are very excited when we are going and demonstrate the capabilities of artificial intelligence applications, especially on the X-ray, because till now we are into that piece. And they showed very much interest, and they actually welcomes us and say, okay, why don't we have a trial settings, or can we do a POC pilot projects and something like this. So I would add into it, yes, there is an excitement, and this is going to be a reality very soon, and the acceptance is going to be very, very fast in India especially. This is my understanding, sir. Thank you.
Oh, great. And just to add, we published one paper at ECR this year, which was, we believe, one of the first prospective studies of AI deployment, wherein one very interesting observation happened. Of course, it was on chest X-rays, and AI would simply do a normal or an abnormal read, and if the case was normal as determined by AI, it would a report would be automatically pre-populated in our RIS system, and all the radiologist had to do was look at the image and confirm that it's correct. We had tweaked the algorithm to always be correct when it was calling something as normal. So it was operating at a very, very high sensitivity, almost close to 100%. But that came at the cost of specificity. So there were always a lot of false positives. And our thinking was that at least whenever the AI calls, it will not miss any abnormal X-ray. That was our hypothesis. But as Vasant mentioned, once we deployed this on the ground, what started happening was that from the user, from the radiologist's perspective, AI was always right. Because the AI would only intervene when it was very confident that a case was normal. So when AI would populate a report on our RIS, it would always be right. But from the user's perspective, that meant that whenever the AI was not populating a report, it was finding an abnormality. Now, as a radiologist, that is a very worrying thing, because you are looking at an X-ray and thinking that it's normal, but you also know that the AI has called this as abnormal, which is a trade-off that we as the implementers of the AI were fine with. But then on the ground, what happened was like our head over there, Dr. Nafisa, she would nudge her colleague sitting next to her and say that I think this case looks normal. But AI thinks there's something there, and AI is always right. So, do you see some abnormality as well? So, something that would take 15 seconds or lesser, ended up being like a full discussion. Of course, the problem was fixed easily by routing the normals and the so-called abnormals to different doctors. But it was one of those interesting experiences where we learned that something that theoretically may be very right can have interesting implications. Dr. Venkat, please.
Yes, so it goes back to what Dr. Vasant was saying. It's about the data, how you feed, how you get the algorithms back. So it's all the input that is really required. So I've noticed many companies, AI companies, initially they are very sensitive. They call very normal X-rays as probably abnormal, which again, as you said, puts the radiologist in a great difficulty. But then that gets better once you start feeding with the data of normals as well. So again, it's a trade-off between how much data and the quality of the data that you put and the output that you get.
Correct. One question, if I may ask, Dr. Venkat, that always plagues people's minds is the cost of implementing AI. Right. If you mentioned that you've already implemented or are in the process of implementing AI, how much can you disclose? Like, how much does it actually cost? And like as large radiology groups in India or the rest of the world, think about implementing, how much of a factor is cost in the entire discussion?
Yes. So since the last few years, about 10 startup companies, many from India and from abroad, have been in touch with me regarding how to provide solutions to various hospitals or organizations, not just India but also abroad as well. So what I feel is, we are all in a bubble at the moment. 2015 to 2025 is going to be a bubble of AI. And when we were tendering as a company, we had looked at 400 AI companies across the world. Of course, we didn't speak to all of them, but this is the amount of companies. The sheer number is just staggering, and they are all well funded because the VCs, PEs, they all have got the money which is channelized towards AI. And I think that time will come when the bubble is going to burst. It has to eventually happen. So now what I think is everybody wants to have faster, higher and sexier imaging and technology and all these things. But what do we actually need? We actually need better patient care, low cost of innovation. Can this new technology reduce our cost to patient care? That is what we have to eventually think of. And when all these companies think about getting tenders and their contracts, trying for contracts, they have to remember that they have to have a low cost solution, which is ultimately the aim. And because there are so many companies vying for it. And I think based in India is a big advantage because we can have the manpower, um, the low cost solutions, which not many countries can provide. So I think ultimately only the low cost, but very effective, efficient and highest quality companies can survive the AI revolution.
Sure. No, interestingly, a question on the same aspect also just popped in, but I guess, you have addressed it to a certain extent. Like, can you provide an overview of the logistics associated and cost estimates for AI to be operational? This is from Dr. Gauri, and how to start the ROI discussion. So I think as Dr. Venkat mentioned, it's more about the impact and the utility that it brings, and how does an algorithm, if it makes you faster and thereby you're able to produce that many more reports, of course there is a cost number that can be associated with that. I wonder, though, and Dr. Venkat and Dr. Kataria, from your perspectives, like, would the cost of AI be, linked to somehow the salary of radiologists across the world? Like, I don't know, like, do you think that would be one of the ways to think about it, or would it be, based on how much a patient pays, or a insurance company pays for a particular, um, algorithm? Just top of my
Yeah,
mind, or
very,
you would have
very,
any
very
thoughts?
good question, Vidur. What I want to say is there is no data as such, but the question that everybody has in mind is the AI solution, if you provide in a, say, example, a hospital or a diagnostic center, is it going to push up the patient that is going to pay? But we can't bill a patient saying that we have AI solution. Patient doesn't know what is AI. Is it going to improve their clinical outcome? Nobody knows, at least at this stage. So we cannot charge the patient for the new technology we come in. We have to implement the technology with no extra cost towards the patient. And in fact, in the future, patient's cost should get decreased, and only then the adaptation will increase. Because to have a big company getting into the solution, so we have to find a solution where we can reduce the cost in other areas. So can we have more effective and cost efficient way of getting patients to attend our appointments? Can we, all the manual work that people do nowadays for fixing appointments, calling them, can we all get that automated through AI solutions? So these are the things that we have to think about, but we can't think about billing a patient for having just AI in our hospital.
In fact, on the patient scheduling aspect, we have collaborators in Brazil, one of the world's largest radiology companies called DASA, where they actually use, machine learning to predict whether a patient will reach on time or not. They use various things like past behavior, socioeconomic strata, the weather, things like that, to figure out if a patient will reach on time or not. So, those are, I would say, low clinical implication but high financial implication applications of AI that are maybe not talked about as much. So maybe,
Yes.
we should get a
So
discussion
we
started.
always talk about the diagnostic aspect of ML and AI, but we
Yeah,
should also seriously think about things like automated appointments, the
absolutely.
report, whether it is being communicated in appropriate time and fashion to
Yep.
the patient or the clinician,
Yeah.
whether we are having a quick turnaround of the patient. So when one patient goes out, do we have an next patient ready? These kind of things. NLP, can the AI software correct our mistakes which are happening in our reports? Can we
Yep.
compare with the previous CTs? So these are, everything is, potentially a viable case for cost reduction for the patient, and
Yeah.
which is what we have to all
No, and
concentrate.
in fact, Dr. Venkat, I'm not sure if you've tried it out already, but I know Vasant is a big fan of this software called Ognito. That's kind of taking the radiology world by storm, which is, nothing but a Google Voice for meant for radiologists,
Yeah.
and it has like a separate Indian accent aspect to it. I don't know like how they figure out what an Indian accent is based on the, I guess the 5,000 unique accents that we have, but and it works fairly well, right? And the doctor's fully in control. You can change everything. So very, very exciting times indeed. One very interesting question's come up, and I know we have about just 5-7 minutes left. Whoever wants to take this is, will technology and maybe AI more specifically change the way radiologists get trained? Whoever wants to take that question.
I will take that. Definitely, ma'am. You
Ma'am,
go
please.
first, ma'am, please.
Well, I can't say about the radiologists, but definitely AI has changed the way we train our staff, and train the residents. And especially in the COVID times, we are doing these distant learning courses. So because the systems are automated and the DICOM images can be transmitted now, we are also for the last few years doing the distant contouring lessons, so they can be done worldwide anywhere. And we send an exercise, the students contour, send it back, do the planning. So, and then we also do the planning here. For the last almost 12 years, I've been using this, that the patient comes to me, gets the treatment done here with me, but he wants it to be verified or ratified by somebody in the US. So I'll have the images sent over on a CD or through the Google link now, and somebody sees them in Boston or in Cleveland Clinic, and they ratify them and then send it back. Okay, this is the right one, and the patient is more satisfied. So nobody's moving, but then it's only information and the data which is moving. So there is a way in which the training and the learning both are changing, for us. So for the radiology, maybe
Absolutely.
you can answer.
Vasant, please.
Yeah, that's quite obvious actually. Yes, the answer is yes, because even we, when we got trained in dark room, developing films, we have moved to digital solutions.
You
There
are
is no
not that
dark room
old,
in any
Vasant.
of the hospitals I know personally. No, I still happen to. But so, and coming to AI, it's possible that maybe 5 years or 6 years down the line, none of the chest X-rays will be read by radiologists. So there might be a time in future, maybe in 2030, when chest X-rays, people prefer chest X-rays to be read by AI than radiologists because they were never trained to do that. It's definitely possible. And one thing, to be kept in mind by radiologists, you should be open to adapt to changes. The change is coming. They're coming with truckloads of money at us, right? When they try to aspire value to AI solution, offering a value that it will improve patient care, it will improve comparison, doesn't strike the minds of investors. But if they point out $100 billion is the total radiologist salary around the world, it immediately captures the imagination of investors, right? So that is the value which they are aspiring to the entire AI industry, investors, and they are coming with truckloads of money. Believe me, and we have to be ready.
No, I think in closing, please, Venkat, Dr. Venkat.
I just want to just expand on the question, Vidur. As colleagues, radiology colleagues, I want to ask Vidur and Vasant, what do you want if your kids want to become radiologists? What do you want to say? Do you want to say go ahead, or do you want to say go
So,
ahead, but
so
with
luckily
specified
for me,
training
I'm not a
programs?
radiologist, so I will outsource that question to Vasant.
No. I have already started. Uh, getting computer courses for my child. He's just 7 years old. Not White Hat Junior, but something else. The idea here is, and I will still recommend him to take
Poor
up
kid,
radiology
Vasant.
because no, I will still recommend him to go to take up radiology because the way I see radiology is going to be, they are going to evolve into what Saurabh Jha, one of our closest friends, used to call as information specialist, right? You are not going to go to the minutest pixel level of the information. You are going to look at gross trends of information. Say, radiologists might be looking at say 100 MRIs in a single day and try to figure out if AI has given a solution. Is it possible that the AI would have failed in this particular case, and I need to look at that? No, that kind of broad understanding of both how AI works and how radiologists work is what is going to happen. That's what at least I believe.
So, and
Yes, I also
ma'am,
want to
please.
add into the
Sorry.
training, because see, as a radiologist, we all have to evolve, we all agree, evolve to adopt the technology, but also evolve to adopt the new training that is required for us to sustain ourselves. So, for example, why don't we have clinics? If we tap a pleural effusion, why don't we have a clinic to see whether the pleural effusion has gone down? Vascular surgeons, vascular radiologists and vascular surgeons very closely work in teams in the UK NHS. So perhaps as radiologists, we should be also thinking more in terms of clinical aspect of training. Whether we should have more patient contact, whether we do any procedure or diagnostic, to explain the clinical findings to an oncology patients. Has the cancer decreased, to show them images? So these are all the things that we should really think about in the future of radiology training, I think.
Yes, truly, sir. Dr. Harsh Mahajan used to say this again and again. Radiologists should stop, sitting in chairs and being armchair radiologists. They should be part of the teams, clinical teams. They should part of the surgical teams, go to the rounds and participate in, hospital rounds. That's probably would help,
I think
maybe.
we are running out of time. We could do this all day, but I think in summary, if there are just and there are questions coming in at this point in time, unfortunately, you won't be able to take them. I'm sure everyone on this panel is more than happy to reply to emails and get on calls and etc. I'm taking that liberty on behalf of everyone. But just in summary, I would say two things. The first is one of the most valuable healthcare companies in India is a pathology company. And pathology and lab medicine are completely disrupted by automation. A pathologist's job today is simply to figure out where will the machine fail. Is this patient on taking biotin and hence the machine will fail? That is the job of a lab medicine specialist. And my wife is a runs a path lab, so I see this every day. How do we take those principles and apply them to radiology? Right, that is the push that how one pathologist signs out 1,000 reports a day. How will one radiologist sign out 1,000 reports a day? Right, that is the first thing. And the second thing, as Vasant also alluded to, Dr. Venkat alluded to, and I'm sure it's obvious to everyone, that radiologists diagnose patients, not images. Right, when you look at an image, it's not just the x-ray, it's the clinical history, it's the age, it's the gender, it's the we are seeing this with COVID. Right, if you see a chest x-ray and you know that the person is married to a COVID positive person, your so-called pre-test probability of a COVID diagnosis is through the roof. Whereas if you knew that this was an X-ray from 3 years ago, you would not even consider. So I think remember that radiologists treat patients, diagnose patients, and not just images. And learn from the world of lab medicine and diagnostics. Pratibha, I hand it over to you now. For closing.
Yeah, thanks a lot. There were so many questions we were not able to take due to paucity of time. Thanks a lot. It was a very rounded discussion. We would like to listen to you more, but we have time constraints here. Thanks to each one of the panelists for making it and giving your valuable input. Was really good to have you all. And you have started the first panel discussion on the first day of the summit. It was really good. So I would like to. Give the speaker certificates here for all the panelists. We have the next Mr. Praveen Nagpal from CR. Yeah, Dr. Vidur Mahajan, Associate Director and Head Mahajan Imaging Caring. Thanks a lot, Dr. Vidur, for moderating the session and helping us a lot for curating this conference.
Thank you. Thank you so much. Thank you.
Thanks a lot, Dr. Tejendra Kataria, Chairperson, Radiation Oncology, Medanta Cancer Institute, and Medanta Medicity Hospital. Thanks a lot, ma'am, for coming in.
Thank you. You're welcome and thanks.
Thanks a lot, Dr. Basanta Kumar Venugopal from Caring Imaging Lead from Caring. Thanks, sir, for coming in and giving your inputs as well in the session. Yeah. And Mr. Vivek Saxena, the National Manager, Healthcare, IT, and Film India. Thanks a lot, Mr. Saxena, for coming in.
Thank you very much. Thank
And
you. My
thanks a
pleasure.
lot, Venkat Ramana from Excel Hospitals. Thanks a lot. Thanks a lot for coming in and
Thank you.
participating
Thanks very much.
in the event.
Thank you. Bye-bye.
Thanks a lot to each of the panelists for coming. Yeah.
And
Thank you.
Dr.
Bye.
Vidur, just want to say that it's 1 hour has gone like 1 minute, so we should probably get back on Zoom and have a chat the whole day whenever we are free.
Sure, sir.
But
Definitely.
thank you, Elets. Thank you, Dr. Pratibha,
Thank you.
Mr. Pratibha,
Thank you, everyone.
and Mr.
Bye.
Ravi for
Thank you, Dr.
organizing.
Vidur, and
Thank you. Bye.
panelists. Bye-bye. Nice
Bye.
talking to you.
Thank you.
As we heard the panelists who were discussing about the future of AI prospects in radiology, we'll continue with our next session where Mr. Praveen Nagpal, the Chief Operating Officer from BPL Medical Technologies, will share his interesting industry perspective with us. Thanks a lot for joining in, Mr. Nagpal. We are looking forward for your presentation.
Yeah. Thank you so much. It was indeed a very deep discussion. What we
Over to
have
you.
seen in, yeah, Thank you, Pratibha. I think it was indeed a great discussion. I was hearing from last 1 hour and understanding, how AI is taking to the next level and how it is
Yes,
supporting the
yes.
patients. So, if you are going to put up my presentation, yeah, thank you,
It's there.
thank you. So, I think the good discussion now, just keeping our gears on that and understanding, how the market is doing and how we are playing in that. So next page, please. So India industry, if we see that it's going very rapidly, in about 1.5 decades, it has moved from about $2 billion industry to about 8 to 8.5 billion dollar. And last few years, it has been growing very strong with about 15% growth. In all the segments, it is growing very strong. If we see whether it's patient support, either it's home health or primary care services, and the products and services related to that, or some of the products, uh, or coming to some of the diagnostic products which are B2B, example CT scans, MRIs, X-ray machines, and some of the other imaging equipment also are part of this. And then consumable and implants, is also a major share in terms of our medical industry in India. And we see that, this whole thing is growing pretty fast, which gives us a platform to execute and see that, how we are going strong in this segment. We see that India healthcare is maturing very strongly. The ecosystem is evolving, starting from insurance, patients themselves, the technology companies are coming, the innovation has started happening, the med parks are coming up. So ecosystem is taking a good shape. And innovation and understanding that, how we can treat a patient much better than previous years is helping this industry to grow very fast. So if we go to the next slide, next please. Yeah. So if we see what are the innovations, and we went through one of the PwC report, which tells us about 10 major things where the innovation is happening across the world in healthcare, and many of them are being done in India as well. There is very much, focus on the patient, and everything is coming from how we can make the patient experience uh, excellent, and they are able to get diagnosed, they get treated well, in the best way, in the shortest time, and in the minimum cost. And then, all these things are going to help us, whether it is less invasive diagnostics, whether it is some of the IT related things in terms of apps, monitoring solutions, digital platforms, and off late, as we heard in the last forum also, that AI is playing a major role in radiology. Some of the other things, how we ensure that connected health comes out, and whether it is diagnosis at patient home or whether it's diagnosis at hospital or clinic, and how we use that data to see that we interpret it very fast, we interpret it right, and we see that patient is better off with all the efforts which are being done. So what's radiology using out of these accelerated innovations which we are seeing in past? So if we go to the next slide, please. So what we have seen in radiology, the bigger equipments have become smaller. And why? Because the hardware has been replaced with the software. There are a lot of platforms which are either embedded or very software based, which has actually taken a lot of hardware related jobs and made all our radiology equipment smaller. So that's very innovative over last 3 to 4 decades, I would say that, which I personally have seen out of that about 3 decades of innovation, and seeing that how the bigger products, where an MRI which used to take 5 rooms is now getting fixed in terms of electronics in one room, and CT scan is now just part of a small electronic cabinet, and that's it. And it used to be three rooms full of electronics. So a lot has changed here. And similar is ultrasound. The big ultrasounds are now you are having an ultrasound in your hand. So a lot has changed around that. a powerful processing. It was initially a slow processing, and data was being processed very slow. Now data can be processed within milliseconds and even nanoseconds. uh, all the products are getting smaller, which is taking less footprint, giving more productivity. We are seeing, and we have heard a lot on artificial intelligence. That is the key thing which we are seeing over last 5 to 6 years, and we see that it will remain strong for decades to come. And this is something, not only take away the minimum role of the clinicians or the doctors, but also help us in those areas where we don't have the penetration and reach of a doctor right now. If you go to Africa, we don't have that many radiologists, and we keep hearing always that, can someone do our reporting? And some of the developed countries, because of the cost, they want to see that how artificial intelligence plays a major role in terms of diagnosis. And a lot happened on the new applications which has come up. Example, in ultrasound, we were never having 1.5 decades back something called elastography. That is changed, and that is helping us, in the terms of cancer treatments. We were having only OB-GYN. Now it has changed to many other things. On CT scans, we were not having cardiac options. It has moved to that. So a lot of applications is being developed. And one thing which is coming up very strong is that from maybe that, the diagnosis is with some kind of information, what we could see from the products is now moving towards definitive. We are getting very strong in terms of understanding what's coming out, and what's the outcome of equipment, and what's the outcome and understanding of a clinician on that. And we are definitely seeing that we have a very strong diagnosis coming out, which is actually helping the patients. So this is a strong change which we see in terms of technology on all fronts, and how BPL is doing in that. If we go to the next slide, please. So BPL is a 50 years plus medical device company, part of the BPL group. And we have a lot of products starting from diagnosis to treatment. If we talk about ECGs and we talk about patient monitoring, which comes in cardiology and critical care, there are strong diagnostic products. But yes, we have other verticals also, which is women and child, and imaging, where we have color Dopplers, we have C-arms, we have X-rays, high-end X-rays also there, and home care vertical along with consumable and accessories. Our production happens in Palakkad. We have a strong distribution network, which is across India. We have more than 100 distributors and about 15 offices, which takes care of more than 600 feet on the street, so that we are able to support all our eminent clinicians, which we cater either in terms of cardiology or radiology or critical care, and we are helping them to use some of the best products what we have done in India. Our clientele includes all hospitals, which is government, private, and clinics, and across the city, across the country. And we are a strong player now for the exports as well. Uh, some of the products come from our UK company, which is Penlon, based near Oxford, which is having a 75 years plus history. And we are headquartered in Bangalore, and ensuring that we provide right infrastructure and support to our products to our customers. When we deal with all that, we ensure that all our team members are properly trained, whether the existing products, the old technology, and the upcoming and the new ones which we have implemented, including the hardware and the software. So we are a very strong R&D, sales, supply chain, quality, and all the functions of ours are well trained to see that ultimately our customers get the best what they have bought for. And we are very customer focused, and ensures that we listen to our customers and see that best comes out. So this is how we are strongly positioned to diagnose as well as treat our customers. And what we are providing to radiology. Let's go to the next slide, and we see that how we are positioned for radiology. So yeah, next please. Yeah. So BPL offer a complete range of X-ray machines, so from analog to a lot of digital X-ray machine, because that's something is very important, especially the detector based X-ray systems for country, whether it's mobile units or fixed units with one detector, two detectors, based on patient outcomes and the productivity required in a hospital or a clinic. And our products are well certified quality products, and it's installed in thousands now, and helping our customers across country. A strong focus on digital presence, whether it is X-rays or some of our C-arms, and we ensure that right outcome comes out of this. Next, please. Similarly, we have a huge range of our ultrasound products. This is based on three E's, what we call it: accuracy, workflow, and design, in terms of all the range of products, whether it is a portable ultrasound, which we have, which is serving our customers, and this can be carried across in the hospital or to various departments within the hospitals, or a radiology can carry to their patients. Mobile units to fixed units, where we have eCube 5, eCube 7, eCube 8, based on the requirement of radiology or cardiology, or it's a combined unit. And with the latest features, that strong pipeline of our products is supporting our customers. A strong install base, and many more customers are using it, yeah, and choosing it for their requirements. A very new technology innovations has been seen on these products, whether it is rheumatology requirement or musculoskeleton or OB-GYN or any other requirement which can be fulfilled. These products, our products are capable to do that. Next, please. So in short, these all products are coming from our factory in Palakkad. We have a strong ISO 13485 factory, which ensures the right quality coming to our customers. Right innovation is imbibed here. They are then produced, and then it reaches India and outside India. So we remain, next please, we remain the committed partner in India to ensure that healthcare reaches to our country at large. I'm open to any questions, and thank you for patiently listening to us.
Thanks a lot. It was very nice presentation. Actually, we are not having any questions right now, so I think we'll conclude.
Okay,
And
thank you,
thanks a
thank
lot
you, thank
for
you,
the time and presentation.
thank you,
Deepak, can we have the speaker certificate, please?
thank you so much.
Thanks a lot, Mr. Praveen Agpal, the Chief of Medical Technology, for participating and giving us a very elucidated presentation. Thank you.
Thank you so much. Thank you.
I would like to, I would like to inform the delegates and the audience. Please use our 3D platform and send us a lot of questions according to the panel discussion which is happening. We would like to have more questions so the sessions can be interactive. We can go and visit our expo stalls, and I would also like to thank our sponsors here who had made this possible. And I would like to inform that BPL Medical Technologies, Fujifilm, Elsevier, Carestream, Icons, Infocom Private Limited, Neosoft, and ACFA. Thanks a lot for being a partner of the first edition of Radiology and Imaging Summit. Next, on agenda is by 1:30 we'll be